It's my pleasure to welcome Jack this afternoon to join us. Jack Rusk is the CEO and co-founder of Cscale, a software platform that is democratizing access to whole life carbon data and design strategy. The last few years, he's presented at a number of conferences. My colleague Andrew mentioned his presentation at AIA 2025, and has also undertaken a variety of efforts collaborating with the previous Biden administration and others to development lifecycle analysis methodology and data solutions for various users. He also is involved in a variety of advisory groups and AIA and other professional organizations working towards better measurement of carbon data and a more sustainable design. With that, I'll turn it over to Jack.
Thank you, Andrew. Thank you, Joel. And I'm sure there's other people on this call that have a hand either in this event or in AIA Connecticut generally. So excited to be here. This is a really nice sized group, I feel, to get into. Oh, hey, Melissa, I know you. To get into some of the specifics and really see if there's, we'll say, like, I'll do little presentation deck, I'll give a little demo, but really what's always more useful than a general demo is specific questions that you have on a project, decisions you're trying to make, things you're trying to weigh, because that gets us out of the clouds and into the dirt, right? And into things you're actually working on. So I want to leave time for that. Maybe as a lead in, with this being sort of, we'll say like a smaller group. Does anybody want to, I'll ask for a volunteer first, maybe help me understand their own kind of expertise in carbon and climate. No wrong answers. I just want to calibrate my presentation to say, like, is this a 101 or a 201 kind of thing? For anybody on this call, like, have you performed an LCA using one-click or Tally, or have you played around with Cscale previously?
Hey Jack, this is Debbie. I'm sorry I'm having trouble with my camera.
No worries.
I have worked with Tally on quite a few projects,
Cool.
but not with Cscale. So I'm hoping to learn today more about Cscale and how it relates to Lead V5.
Awesome. Great
Thanks.
tee up. Thank you, Debbie.
I mean, I can jump in. Paul Jorgensen. I belong with the Connecticut Department of Housing,
Cool.
and I would say this is a 101 type course for me. We see a lot of projects that come in that focus on energy and operating costs, but carbon, but do not talk about carbon, embodied carbon, for instance. So I'd like to see what tools are out there and further that discussion in my office.
That's awesome. Okay, Paul. Well, this is exciting because really what gets me going is how we use tools and data actually to understand, we'll say, trade-offs between things like operational carbon reductions, energy efficiency, and things like embodied carbon. The reality, obviously, on any particular project is that no one has the time, the fee, or to do everything. So the question really is always, what's going to matter most? And then after you do that, well, what's next on deck? And I think it has actually been a long, we'll say the emergence of the conversation on embodied carbon really comes out, I think, directly in many ways of all of the amazing work that's happened for the past few decades on energy efficiency, right? And electrification. As our buildings get more efficient, as we electrify, you look at the same building and you see immediately that the largest hotspots, the largest contributors to the building's emissions, right, are the materials that make it up. And then in many cases, if you're not able to reuse the energy, if you're not able to electrify, those are still the biggest parts of the pie. So let's put a pin in that and we can come back to different ways of thinking through the kind of balance between operational and embodied carbon, which is especially relevant for retrofit projects, which I know at least some folks on this call work on. Okay, I'll use that as a segue to begin a brief presentation. Again, I don't really want to present for more than 20 minutes because I want to sort of get to some specifics and practical examples, but I think it will be nice we'll say with this being something like a 101 to sort of do some level set that I hope is also interesting for folks on this call who, like you, Debbie, have used Tally previously and have a little bit more, we'll say like experience with LCA in practice. So Jack, C-Scale, our idea, like I said earlier, is that we are really excited to use data to drive decarbonization strategies so that people can target the decisions that matter most. On any particular project, there's like 3 or 4 things that make it into the award submission, and then 100 other things that happen on the project, right? Like in the process of design. Our goal is to build tools and provide data to help tune those decisions towards better outcomes, whether or not they are the big shiny statement that gets put in the marketing materials. So in this sort of like, we'll say line of thought about it being data that drives decisions, I'll sort of start with some level setting about big statistics we often hear, and no presentation about buildings and climate would be complete without what I've begun calling the dreaded statistic. This idea that 40% of global emissions can be attributed to the building industry. You know, it's a big number. It's a scary number. We all have some part to play in this. And when we look at it, like it's sort of just intimidating enough that it's a little hard to approach. What does it mean to take this down to 39%? What can I do? If we're looking for data to drive decisions, these are nice sort of statistics to sort of contextualize what we sort of should focus on. But I argue that maybe statistics like this don't actually help us focus our attention on specific, we'll say strategies and practices. Another kind of global statistic that I find really fascinating comes from the UNEP, sort of the global group convened by the UN to look specifically at buildings. And it gives us this other sort of very staggering way of slicing some of the same facts. To reduce emissions from the built environment must happen simultaneously with a growing building stock. There's all sorts of arguments made, I think, like, and we can, many of which have merit about, building less, about, we'll say, trying to provide for sort of the programmatic requirements of clients with things other than a building. But at the end of the day, it's a little hard to convince a group of architects that they should build less buildings. And that really helps us understand the challenge, which is to how do we continue to provide spaces for human thriving, right? While also reducing overall emissions. And this means that if we're going to build, twice as much, say, and reduce emissions by to half as much, every building we build, we need to do a little bit better with, especially because not every building is going to get the attention of an architect, least of all one concerned about the sort of environmental impacts of that project. Another kind of statistic that sticks out to me in these conversations is this one. It comes up sometimes about this is from a study in, I think, 2020, that the weight of all the stuff moving through the built environment, you see the things here, concrete, aggregate, bricks, like masonry, metals and asphalt, now outweighs all life on Earth. It's sort of a strange thing to think about, but it really helps us understand this sort of twin crisis of landscapes and biodiversity together with, right, all the material being processed in the built environment. And again, like another way of slicing the global problem, and one I hope that's a little more palpable to people, we'll say like very aware of the quantities of things like concrete that might go into a building. And all of this obviously is, depressing, demoralizing, like et cetera, and we could sort of stay up all night feeling bad about it. But the thing that is really exciting for me at C-Scale, and I think for many folks in the industry, is that designers actually have a very particular and powerful role to play in this whole kind of equation, which is that like the procurement, right, spend that comes through architects' hands through things like specifications, which obviously aren't the whole picture, like, specs get eroded for all sorts of reasons, but really they do move and define markets. And the potential of architects and designers taking climate more seriously is that the immense purchasing power of all those hundreds of small decisions that people make every day has the potential to really do something, different. On one hand, our decisions, right, move mountains, they contribute to extraction. Some of this is inevitable, and really, I think, a cost worth paying for a like beautiful and livable cities. But we can also try to make decisions that regenerate forests, that rebuild livelihoods, that repair landscapes. And the trick, obviously, is knowing which decisions contribute to which. To do that, our work to sort of bring it home is life cycle assessment. Life cycle assessment is the tool that helps us tell the difference between things that contribute to environmental well-being and things that degrade it. And obviously, carbon is only one of many metrics we can look at, and we look to carbon really as a imperfect proxy for a whole host of potential impacts. Like I was mentioning to Paul earlier, we're needing to look at energy use in a building against the procurement of insulation, against the effect that improving the concrete mix, right, like might happen. And what carbon allows us to do, it has this sort of magic quality, just like currency, of helping us put dissimilar things on a common basis. And that's why we see carbon assessments as a holistic frame to make these sort of like decisions on building projects when buildings are many dissimilar materials coming together in complex sequences, and to wrangle a lot of that complexity, these sort of simplifying assumptions like reducing everything to carbon emissions helps us really wrangle this to be able to make apples to apples comparisons as we're approaching these decisions. What sort of decisions? How much you build, which structural system you use, which materials you procure, how durable materials, right, should you be looking at? Should you electrify? Is electrification better or worse than just efficiency? How do they stack up together? Are on-site renewables worth it? Do I plant a landscape? What does that landscape look like? And most crucially, how all these things interact. So this really is the decision space that we're sort of looking at in C-Scale. And why we think data and data-driven tools and C-Scale is, I think like something we're really excited about. There's a whole host of things like this in the EU and actually a few coming out of New Zealand right now, all trying to think through these processes. Is that really at the early phase, very little is known about the project. This is the classic. If Dov was here and not teaching professional practice, I'd put him on the spot because I think I learned this in professional practice. The McLeamy curve, if you guys have heard of that early in the design, you have a lot of agency to make the big decisions, but you don't know anything about the project. There's no data available. Later in the project, you know a lot, the building's designed, you have a very rich Revit model, you're interacting with the contractor, but your agency to affect change in the design is, constrained by all those same factors. The goal is to get people more data earlier to make better decisions. And the reality is that early decisions are complex. So this is like a kind of way of walking through some of these complexities. This is a project that I worked on in San Francisco a few years ago, a K-12 school, about 100,000 square feet. And this is really the mix between operational and embodied carbon. The grid in California is pretty clean. It's getting cleaner. And we see that most of the emissions from this school are from the embodied emissions. But if I take that school and, put it in a crane and swing it over to a couple different cities, we see really different profiles in the distribution of emissions and also the absolute quantity. There's different electricity grids, there's different concrete supply chains, right? Concrete's an exceptionally regional material, and that changes the balance between operational and embodied carbon. And obviously, like if you're in, one place and you're only doing projects in one town, you might get to know these dynamics sort of like, like you might develop a gut feeling for it. But the reality is that many architects work across geographies, work on many different project types, and need to use data to understand these trade-offs, lest we accidentally design or make decisions that might be relevant in San Francisco that are not as relevant in a place like Salt Lake. Another kind of like thinking that we hope data helps us avoid is the idea that there might be a magic bullet solutions, like the one thing we should always do that works everywhere. So this is sort of continuing that same analogy. Say for that San Francisco school, we put a PV array on it and we get to something that looks like net zero. We generate enough energy in the year that all the energy procured from the grid, right, is we'll say like averaged out over the course of those 12 months. Well, if you take again that same PV grid and put it in different places, you see really different dynamics. In Seattle, the grid is way cleaner, but PV actually produces much less electricity because it's cloudy all year in Seattle, and we don't get to net zero. In Albuquerque, emissions are much higher, but so is the amount of solar resource. So you get to something that looks like net positive. And again, these dynamics, which are evident once you sort of start to stack them up and look at the data all together, are not always immediately intuitive. So C-Scale has its roots in the idea of a decision-making tool to help bound out all this complexity to help project teams focus on solutions that matter. The right data at the right time to support the right decision. And this is what I talked about earlier, right? Like project data, really, if you read from sort of left to right here, when you are doing things like trying to win the project or say design the project, you know relatively little. And it's only by the time you have all the construction, you know, the as-built, and you're able to look back, you can really understand the full impact. But the fact of the matter is that we need to be making decisions when there's relatively little project data. And C-Scale's approach here is to use comps, to use models, to use reasonable assumptions to fill in the context earlier, to allow people to do things like at the project proposal phase or an early design, make impactful decisions. You know, it will say like with full context. The idea that as you design, you are setting the whole building strategy, making the large moves, focusing on enclosure, maybe structure, digging in a little deeper to material procurement, and then configuring assemblies as you sort of figure out the way that some of the assemblies are going to come together. And then finally selecting materials and using environmental product declarations, which I'll talk more about during the demo, but it really is just a kind of encapsulation of a product's environmental footprint. And it really is when we're comparing something like, you know, concrete with one mix versus concrete with another, we're using these environmental product declarations to be able to make these distinctions. But they really are the way that we understand products and the things people sell into the market as being low carbon or otherwise. This allows us to address the hotspots in design iteratively. And something I'll talk about some today is this becomes really crucially important when we look at retrofits. Because in retrofits, we have to not only think in a given year, but we have to think over time. Retrofits are often, you know, buildings live a long time. And when we're balancing embodied and operational emissions, we're really balancing emissions today, the embodied emissions that are emitted when the building construction happens, with emissions that happen tomorrow as the building operates year over year. So we can look some more at this as well. A briefest, like looking at the time, like kind of case study to walk through that really is like some of the early work that we did on C-Scale. Back in yesteryear when C-Scale was a project with an EHTD, an architecture firm in San Francisco and Seattle. And we were going after the AIA headquarters renovation. Big, brutalist building, right? Like can't insulate it very well. Details are difficult. But, you know, there's this ambition by the AIA to set this up as a net zero project. Early in the proposal phase on day zero, the project team, including myself, used C-Scale to set targets for the project that combined electrification, energy efficiency, a low carbon retrofit with a local carbon offset project where solar PV was installed at Habitat for Humanity projects around Washington, D.C. And to do these installations, we had to know exactly what the last amount of embodied carbon to offset was, which means we needed on day zero of the project to have that number and feel confident in it. And it's really exciting today to think back on this project because it is finalizing the gala. The opening gala was held, I think, a month and a half ago. And we're finally on the other side of the project, and the final carbon estimate, or the sort of measured as-built carbon emissions, were within 5% of our initial, you know, day zero design. And that doesn't mean that C-Scale was exactly precise in estimating it. It just speaks to the power that having an early target that you can defend with data is what helps you understand where you get at the end of the project, if it's meaningful if it's correct, if it's within your goals. And this really is, I think, for us, the biggest advantage of setting carbon targets early and iteratively is because they help you understand, right, what the North Star is and what good will look like for that project. So since then, Cscale is now a separate company, has no sort of day-to-day relationship with EHDD, and it's still available open access online for anybody to use to go in there and plan projects. There's different, we'll say, like parts of it that are subscription based, but our goal is to provide the majority of the functionality for free to everybody, with our goal of getting, a carbon assessment done on every project by every firm everywhere. So I'm going to transition here to a demonstration, but before I do, I'll pause for a minute for questions and discussions if anybody has thoughts to share. All right. Let's dive into a demo. So I'm going to pull up the app, which means I'm going to share again and go to a browser window. And you see here, we'll say like the interface that you get to when you first log on, which is all the projects across the firm. One thing that we've been really excited about and working on at Cscale is with all the firms that we're working with, trying to help them approach these things not as a scope on a particular project, but really as a firm-wide kind of approach to understanding their projects. So you see here that we're logged into an organization amongst many organizations. You have access to all the projects. You can see who's edited them recently. The idea that these are sort of collaborative environments where many people work together. I'll go through briefly the project creation process. We'll look at new construction, we'll look at a retrofit, and then I'll sort of show how to dig all the way in and look at products, or zoom all the way out and look at portfolios of buildings all together, which is useful for planning. I was actually on a phone call with a firm in Boston an hour ago that's going to use Cscale to serve some of their campus clients across Massachusetts in doing campus-wide planning to help the campuses marry their decarbonization plan with their capital plan by understanding all the projects moving forward and how the campus as a whole can move towards meeting those goals together. But the idea here is that you can create a new project with very little data, just the things you would have on sort of like the first page of the RFP. And then from there, you can dig in, iteratively add detail until you're right up against something like Revit. And it's going to be one of our major efforts in 2026. We should have some news to share there in the next month or two to get you into Revit and connect your design data, your primary design data, back to Cscale. And that'll be, I think, exciting. But the reality of early project phases is actually often BIM isn't available. We're working with massing models. One company calls it digital blue foam, right? We're sort of doing this like preliminary modeling that's not yet highly detailed or defined in a Revit or other kind of BIM environment. So if this is sort of, we'll say, a Connecticut campus building, I'm going to enter just a few points, and we can use that to understand the overall missions of what a typical building is and plan some decarbonization scenarios. So I'll call it new construction, completed in 2026 in New Haven, Connecticut. That brings us across the country to New Haven, Connecticut. We'll call it a university building, maybe with 3 floors and 120,000 square feet. Maybe it's a big flat thing. There's all these different ways you can set scope or auto-generate scenarios. I'm just going to You can look at the custom scope. Let's look over 30 years, maybe. Let's look at only structure, enclosure, and interiors, and I'll do no auto-generated scenarios. You can accept the defaults, you can pass it on, whatever works. So that creates the project and brings us to the project interface. The briefest overview of how this is organized is you have project level details here, all the different scenarios you create here, and really all the modeling choices you're making are on the left-hand panel. So this is a business as usual building. I might look at the project settings just to walk through them. General, project number, year of completion, location, we looked at that. Use, if there's a secondary use, you can put it here. Building size, maybe there's below ground floors like 2 at 5,000 square feet, right? Whatever that is, that'll update the model. We're excluding site work, but we can put it in. This is assumptions about the electricity grid and if and how and when it will decarbonize in the future. Energy benchmark data as is relevant. And then we do refrigerant modeling, relevant for lab buildings, grocery stores, data centers. But let's just consider it out of scope for this building. And I can always change that scope here, adding in, we'll say, other scopes to the project. So the idea is you can sort of like configure all of these things at the project level, and then really everything else happens here, building scenarios. The first business as usual scenario, we'll call it the baseline. And you have to click in to edit the baseline. The baseline has this sort of extra layer of protection on it, because you'll see as we generate other scenarios, they'll give you sort of reductions against the baseline. So here we can check this. Actually, maybe the floor to floor height is more like 16 feet. And the building is really glassy. So the window wall ratio is something like 0.76, whatever that is. You still sort of update the preliminary takeoffs there. I look at my energy use and hey, maybe my baseline UI here is, 40, whatever that is. You see my benchmark UI. My benchmark is always going to come from the industry-wide benchmark, which lives at the project level. So that's sort of industry-wide data. So I'll accept this as my my baseline. Let's go through some of the graphs. This is cumulative emissions over 30 years. So you see the big spike in year 1 of embodied emissions and the slow accrual of emissions over time. If I change this from an all-electric to a mixed fuel building, you see 2 kinds of emissions, both the on-site combustion and the electricity emissions. Maybe we'll have a mixed fuel baseline. What I was saying earlier, if this is one way of looking at it, where we look at the, say, the 30th year, and operational emissions are the largest overall cumulative contributor. If I look at the data annually, we see a very different story, right? That the biggest single emission spike is the embodied emissions in the first year. So there's this trade-off, lots of emissions up front or little emissions slowly accruing over time. We'll start to look at that. You can break these emissions down by the contributors, energy, structure, enclosure, interiors, construction activities, maybe no surprises there. And you can summarize the data into some large chunks and even start to sort of benchmark your building against the Carbon Leadership Forum. So that's the sort of general orientation. Maybe we'll build a scenario. The first scenario, I'll just call energy efficiency. It'll copy the baseline and make a new scenario. And I'll use this and I'll reduce this EUI to something like, 20, a very low EUI. You start to see what that reduction looks like. And heck, maybe here too. Actually, I'll make another scenario now. I'll duplicate this one. And I'll call this one actually energy efficiency plus electrification. And for this scenario, okay, I'll also check the electrification button. And I can start to compare them on the Compare Scenarios tab in different ways. But you can see here this sort of progressive reduction in emissions with each scenario. And maybe I'll make another scenario by continuing to duplicate these down. And I'll call this one energy efficiency plus electrification plus PV. And I'll put a PV around this building that generates, whatever it is, 50% of the total electrical load. And that gives me this new scenario. It tells me the area of this array around 22,000 square feet. That's great. Maybe I, have checked, we'll say like with an engineer, I've looked at the site and I think I should actually, there's, massing reasons why I'm going to angle this a little differently. So the azimuth, right, 180 degrees is south. Maybe this is going to be a little bit to the west. So I'll put this at 230 degrees. Everything else will resize accordingly based on production at that orientation. So you can do like really easy mock-ups of these sort of initial scenarios. And I'll mark this as the target. And it gives me now all of a sudden this sort of first suite of scenarios that has really only been focused on operational energy. But we see here this pattern emerge where as we've done the sort of commonplace measures, as you mentioned, Paul, to reduce operational carbon, with more efficient buildings, electrification, sprinkling of PV panels, we see this very clear signal that everything else we have to address here is going to be, we'll say like, embodied carbon. Andrew, I saw you turn your camera on. Was there something you wanted to jump in with?
I had a quick question.
Please.
Well, whenever you toggle the PV array on, it seems like there would be an addition to the embodied carbon in the building, but maybe that's like so small that it's practically negligible, or is that not in the
No.
platform?
You're really onto something. So let's this is a scope issue actually, because when we go back to the scope we're including, we're only including structure, enclosure, and interior. So let's turn on sort of services, MEP, et cetera. So we turn on services. Okay, this will it'll take a second. It has to recalculate all of these, right, with the new scope. And then we can start to see actually if in 30 years, the PV pays itself off for this scenario. So now, okay, we have these scenarios. So let's go back to compare scenarios, summary, and you can see here the difference starts to emerge. So we have this embodied carbon emissions, 540 kg CO2e, this one, 553 per meter squared. So you see there's an increase in the embodied emissions.
See it, yeah.
And it pays itself off. But you will find for sure if you're in a place like, this comes up and it's, if you're in a place like Seattle where the grid is very clean and the electricity you just get piped in, by the utility is already looking pretty good. The PV trade-off is a little different. And this is where we need to sort of put an asterisk to say that, and you see the same thing with insulation sometimes, sometimes triple glazing isn't worth it from a carbon perspective, but it's still worth it from a comfort perspective. It's still worth it from, we'll say better detailing or moisture management perspective. And there might be places where PV doesn't pencil out from a carbon, angle, but it's still meaningful because, hey, maybe it provides resilience or these other benefits. So we do get sort of not angry, but sometimes and say my PV array isn't doing exactly what I thought it would do. And that's where we need to sort of politely lay out these, realities of these trade-offs that exist. But great point.
Good, thank you.
Okay, cool. So with this sort of set, Paul, the stage is set to move past, we'll say, what you've been working on so far. Sorry to use you as a shill in the audience, but I think you teed up pretty well. Moving beyond what people are used to and looking at some of the, we'll say, more the embodied emissions. So if I go back to this scenario, and actually as another fun thing, let's stick around on something like the comparison. And this gets to sort of what I was talking about earlier. If I go to project settings, I know that Pickard Chilton, from what I understand, has some big Chicago projects. And if I move this same project to Chicago and it recalculates, we didn't sort of export the data so exactly, but I hope you can see already that this is sort of a different orientation of all the numbers. Savings are larger from electrification, PV, saying it's 50%, that's just what we set it at, but it's a smaller number. And you start to see the way that geography is really going to affect what we're going to see. But we'll move back to New Haven. just to note that all of the data in that presentation comes, straight out of the tool. Let's see if I can plug this in a way that it likes. Okay, now I have to wait for it to reload again, sorry. Okay, we're back. So from here, if we look at, say, this scenario and look at the life cycle emissions, we see that all of a sudden energy use is not the largest contributor, structure is. So I'll make a new scenario, again, just copying it down. So I'll duplicate this and I'll call this just, operational carbon plus embodied. And I can start to layer in some low carbon design strategies. So I'll start with structure. You can do sort of like, we use statistical models. That's a whole other presentation. You might have seen me give some of that, Andrew, at the AIA conference to do these estimations. But I'll just sort of talk through the results here as we can look at things like structural efficiency and say that we're going to be, relatively more structurally efficient. And that will reduce the carbon emissions. We can procure lower carbon materials. And this starts to lower that number. But so reductions, and you can start to see these three choices. You didn't see it maybe when it was scaled, but now we can start to see that actually just those three choices I made, lower carbon procurement, a more efficient structure, you see a meaningful reduction there. Maybe there's a way where instead of being reinforced concrete, I model this as a 3-floor building. So maybe I'll say that there's let's just see if we can use something like wood frame for 33% of the building, maybe just the top floor, who knows? And you start to see that, reduce it forward, we're at 39% now. And really what we're doing here is just chipping away at the emissions, one thing after the other. Because now I have a wood structural system in play, I can, claim responsible sourcing for that timber, and we start to see the stored carbon in that timber show up as well. If you do mass timber, this will obviously be a bigger number. But this really is getting at some of these dynamics with trade-offs between all these systems. So if you want the raw data, you can look at this sort of chart down here to understand the trade-offs and differences. All of these, again, are versus the baseline, these percentages. And then from this, that structure, I might look at enclosure, which is where architects spend a lot of time. And I can say that this composite metal panel has this carbon intensity. Maybe I actually want to try out ethos, always a popular choice. And you see that it has a lower A1 to A3 carbon intensity. Well, one good reason to feel good about ethos, just kidding. That there's like these things you can start to get at, right? The way these materials affect each other. Different, maybe it's a curtain wall system, maybe it's a window. And this again is really high level modeling. You see these service lives too. If I go actually to just the time series, you see these little bumps that happen as the emissions change. Maybe this is a more durable assembly, 50 years, and you see that the bump will start to change in turn as these emissions happen in different years, which is especially true for commercial interiors projects where sometimes the service year is very short. And you have many bumps over time as the emissions from these sort of replacements of materials occur, right, many times in a 30 or 60-year period. But that's like the high level design. We can dig a little deeper by going into detailed design. That opens this other more complex panel. And this really is where you can dive in. Okay, this EFIS assembly is made out of these materials. If I change this to something else, like a thin brick rain screen, you see it'll recalculate all of the materials coming into that. And if I say, well, I don't typically use, this or that, you can sort of break open one of these assemblies and you can get in and you can start to edit the aspects of any particular part of this assembly. Maybe this, whatever it is, this insulation, you're going to count elsewhere, so you can remove that. Maybe you want to add a new entry with a new kind of assembly. You can change the total quantity in meters squared. You can change for any one of these. You can change the quantity per area of assembly. So start at the high level, move the big levers. Then you can start to look at these assemblies. And again, like you see what here is the largest contributor to those emissions. And you can sort of slowly work that down one thing at a time. Viewing the data, one way or another there. And then from there, there's things we're working on now. And this really is live, but we're working with building transparency to get all of the, let's just type in cladding. There's all these different sort of like cladding assemblies, et cetera, that we're starting to get in here. You see a lot of the data needs to clean up. So you can't use this in modeling yet because it very much is like early to this. But now, as this is maturing, hey, maybe I want to compare, some of these assemblies. Okay, that's just trim. So I'll compare this and this and this, and you can start to compare products, read about them, get the EPD, manage a little product library, and try to sort of slowly put together the set of EPDs you'll use on the project. And to Debbie, your question, this is what's getting us in line for a number of LEED v5 credits related to EPD management. While at the same time, the building level modeling helps get us to some of the LEED v5 credits related to carbon emissions in the material and resource category, while the operational energy modeling I did earlier is part of their new total carbon prerequisite that requires actually a graph just like this one to understand carbon emissions in any given year. So that's a lot of the modeling you can do. You can export any number of sort of reports from this, a PDF, for reporting to the DDX, which a bunch of folks are doing right now with C-Scale, the raw project data as Excel. And then crucially, all of these projects you build one at a time, get rolled up into these portfolios, enter kind of a random one that takes all of the individual projects and starts to help you benchmark across them, figure out what the hotspots are. And this is a fun one that we were working on with Architecture 2030, which helps us understand again that the operational emissions are not the same thing as EUI. So if I sort this by EUI, we see these high EUI buildings that are exceptionally low emissions. This is because Vancouver, right, has a very clean grid, and also because things like a clean power purchase will affect this, together with these projects, right, that have a very high or higher, maybe we'll say, operational emissions, but a lower maybe EUI. So helping firms understand the differences in these patterns across their portfolio, helping sort of, this is a kind of graphic we've been working on with campuses, which is understanding cumulative emissions across things. So I can look at this annually, and you can start to see when projects happen, different things come online. If I change the emissions view to projects, you can see which project is occurring in which year. And this really is, again, that while maybe people are modeling specific projects, firms and clients are looking at campuses, they're looking at groups of buildings, they're weighing strategies across buildings, right? Trying to understand where the biggest reductions are to be had. So I'll pause again there. I think, how are we doing on time? We've got about 15 minutes left. Maybe you can get in some questions or specific cases.
This is great. It looks like you've really developed a full-featured platform. Is there, what do you think the biggest thing that's missing from it is at this point?
I mean, usually when people think about buildings, they think of 3D things, right? And that really is like the hill we're climbing now into 2026, Revit, right? Like closer to the source of truth. And I think like there's things we don't need to do that yet. Like a lot of good stuff happens before BIM, but at the end of the day, like if you're not in a BIM environment, it's hard to maintain good connections with the project into later design phases.
Mm-hmm. Is there any thought about C-Scale making suggestions?
It does. So let's see. Yes, there is. We don't know exactly how yet. I think because like there's two layers to that. One is suggestions at the highest level, like here's some, you should consider electrification. Here's what it does. Another is suggestions for specific products and materials.
Mhm.
Hey, we see you have a brick building. Here's 3 cool bricks you should look
Yeah.
at. And I think those, well, I don't know, like we've put that off basically because it seems like a convenience feature while we're trying to develop a lot of the deeper functionality. Because I mean, we try to make it look easy, but we have like a full-time staff just cleaning data. You
Oh
know what
yeah.
I mean?
Yeah.
But as you're trying to use it and try it out and blah blah blah, like let us know where you might see relevance there. Because at the end of the day, like everything we build at this point, except for a lot of the raw data processing, like gobbledygook, comes from other people's ideas. Because somebody says, like earlier today, this large Boston planning firm says, I need to provide this kind of graphic to this kind of campus client I'm working with. Okay, yeah,
Mhm.
like we'll go build that for you, you know? So if you're like, yeah, all to say, like, super open to it, um, and try it out and let us know maybe more specifically what would be useful.
Yeah. Cool.
I see that Lane does have a question in the chat box for you, Jack.
Hey, I see it. Can you customize material EPD if it's not in a database? Is there maybe a
Hey,
do you want to fill in like details there?
so our firm, for example, has been using Tally, and
Hmm.
one of the challenges was that not all materials are present in the Tally database, and there's no option to customize that.
Yeah,
Or like add in if we have the EPD and it's not in the database, can we fill in the information?
I
Yeah.
understand. So there will be we're building our own EPD library, working with building transparency as mentioned. And then from that, EPDs are tricky documents because they all sort of mean
Hmm.
different things. But the
Yes.
goal, our North Star there is to be able to make the oops, I'm in a portfolio. Those EPDs, once the data is cleaned, available within the application, so that whatever this
Hmm.
GFRC, this stucco thing is, right?
Hmm.
Right now, you can save it to a project. You can look at some of the data. We're slowly building out the ability so that soon you can use this within the model. And
Okay.
Tally 2, as Tally 2.0 is developed, will do the
Hmm.
same. And we have a very close working relationship with building transparency so that
Okay.
C-Scale and Tally 2.0
Okay.
can be pretty tightly
Is there any
integrated.
correlation between your software and Tally, you're saying?
So Tally is in the mid, like Tally 1.0 is getting a little long in the tooth, hasn't been updated in
Yeah.
many years. And
Okay.
there's efforts underway to figure out something like a Tally 2.0, and we anticipate close integrations with Tally 2.0
Okay.
as that all comes together because it is like this major, uh, we'll say
Yeah, and the
like obstacle.
integration with BIM is the biggest thing, I would say.
Totally.
Yeah.
If you send me an email,
Hmm.
I can send you. There's workarounds that people use to get EPDs into Tally. I'm happy to sort of like send you. There's a set of email threads that people keep forwarding around about how to do that. If that's of interest to anybody,
Yeah,
just let me
that would
know.
be great. Thank you.
Cool. Yeah, yeah, yeah.
So I did have a follow-up question about you were saying each project would create its own list of materials proposed, materials used, and you would enter in your EPD data into that. So you're not just picking it from a list, you're actually in the products you specify for your building, you're going into the manufacturer's information and trying to determine what you're entering into this model. Correct?
It,
It's
it's
not as simple
it.
as I want to pick this material versus that material. I mean, I want to see it in both scales. I want to see it in the big
Yeah.
picture of what are my alternatives to begin with, and then as I focus in on different parts of the building, enclosure, structure, whatever, and then start to compare products through that. And then use the model maybe that it spits out the data and says, okay, yeah, you're doing much better here. And I would imagine that could be tricky based on location alone. Some of the embodied would be different because it's a local material for this market and not for that market, for instance.
You're
Like
getting
you,
at a lot of the, yeah,
yeah.
kind of core complexities here. I think the other just thing to reckon with is most EPDs are still published as PDFs. And Building Transparency, a nonprofit at the center of the space, has done a lot of work to digitize it. And there's some, folks come on board now to do better, do digital first EPDs. But like, I mean, I hate to say that's still one of the major obstacles, but it really is still one of the major obstacles. If you're dealing with super messy PDFs. I think you're really anticipating some things worth thinking about as well, to understand alternatives, to dig in. I'll show one other thing that might be that's exciting to us, we'll say, when we think about um, some of these dynamics is we've been working with some interior design firms on sort of like, I didn't show this in the call, but it's a more detailed view of the interior's emissions. And we are proud of, I don't know how to say it, like this graph that we make, which takes all the emissions across all the different contributors to an interiors project and just ranks them with really the idea that as you're doing this sort of deep dive, you should only worry about these three things, right? Like you can worry about these 50 things over here, like at your leisure, you know, but really by, better glass partitions, better framing details and materials, and better acoustic tiles in the classrooms for this particular building, you'll address most of the impact of this project. Sure, there's other stuff you can think about, the workstations, the doors, other task chairs, etc. But it's exactly like you said, kind of digging in. Okay, what material do I use? Where does it go? We see graphics like this as helping designers and decision makers just focus their attention on what matters and bracketing out all that other noise, lest somebody gets just distracted, right? And burns fee or burns time on decisions that like won't move the needle.
Mhm. That kind of goes to my first question too about whether C-scale would make suggestions. In a way,
Yeah,
that's what you're doing there. Yeah.
in a sort of passive
Suggestion
way,
about suggestion about where to focus
exactly.
your attention.
Uh-huh.
Yeah.
Because I mean, that's so much of this, right? Like, there's always on any project 100 things you could do. How do you figure out what of those 100 things is most meaningful?
I was going to say, I just, if there are any other questions, I want to thank Jack again for doing this. We, on behalf of Gav and myself, we really appreciate you joining us today and